Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video we are going to learn about chemical oxygen demand. So we will learn what is chemical oxygen demand and how you will calculate this chemical oxygen demand. In short form we called it COD code. In environmental chemistry, the chemical oxygen demand is an indicative measure of the amount of oxygen that can be consumed by reactions in a measured solutions. My friends, chemical oxygen demand is a measure of the capacity of water to consume oxygen during the decompositions of organic matter and the oxidation of inorganic chemicals such as ammonia and nitrite. This is also very important point related to chemical oxygen demand is expressed in milligram per liter, which indicate the mass of oxygen consumed per liter of solution. Now, chemical oxygen demand or COD is a measurement of oxygen required to oxidize soluble and particulate organic matter in water. So, the temperature of stream water influences the amount of dissolved oxygen present. Less oxygen dissolved in warm water than cold water. For this reason, there is a cause for concern for stream with warm water. Trout need DO level in exceeds of 8 mg per liter. Stripped base prefer DO levels above 5 mg per liter, and most warm water fish need DO means dissolved oxygen in excess of 2 mg per liter. So why? Why is it important? Chemical oxygen demand is an important water quality parameter because similar to BOD, it provides an index to assess the effect discharge wastewater will have on the receiving environments. The higher code level means a greater amount of oxidizable organic materials in the sample, which will reduce dissolved oxygen level. So, a reductions in dissolved oxygen can lead to anaerobic conditions, which is deleterious to higher aquatic life form. The code test is often used as an alternate to BOD due to shorter length of testing time. Now, source of BOD and COD, mainly from domestic and industrial sources. Some examples are given below. You can see medium strength domestic wastewater BOD 190 mg per liter and COD 430 mg per liter. So textile wastewater 197 and 2497. Paper mill wastewater 93 to 633 and 571 to 3085. Landfill leachates 20 to 557,000 and 140 to 152,000. So BOD versus COD. What is BOD? BOD is the only measurement of consumed oxygen by aquatic microorganism to decompose or oxidize organic matter. But COD refers to requirement of dissolved oxygen for the oxidation of organic and inorganic constituent both. Although some of the organic compounds which can be broken down by microorganisms are countable for the biological oxygen demand, and they may not be encountered in measuring chemical oxygen demand. So environmental significance. What is the environmental significance? The COD values are particularly important in the survey designed to determine the control the losses to sewer system. So the ratio of BOD to COD is useful to assess amenability of waste for biological treatment. The ratio of BOD or to COD greater than or equal to 0.8 indicates that wastewater highly polluted and amenable to be biological treatment. It is useful to assess strength of wastes which contains toxins and biological resistance organic substance. Now, procedure for COD measurements. It is important to understand that COD and BOD is not necessarily measure the same type of oxygen consumption. For example, COD does not measure the oxygen consuming potential associated with the certain dissolved organic compounds such as acetate. However, acetate can be metabolized by microorganisms and would therefore detected in the assay of BOD. In contrast, the oxygen consumed potential of cellulose is not measured during the short-term BOD assay, but it is measured during the COD test. Now, procedure for COD measurements. Two types method for COD measurement: open reflux method and closed reflux method. Mostly use the open reflux method because closed reflux method is produce the minimum hazardous waste but cost advantage. Now, open reflux method. You know, my friends, the sample and blank can are reflux in a strongly acidic solution in the presence of a standard potassium dichromate solution for 2 hours using a reflux apparatus comprising of an aluminum flask, a vertical condenser and heating mantle. So the remaining unreduced dichromates of the digested sample and blank are measured by titrating against the standard ferrous ammonium sulfate FAS and solution using ferroin indicator. You know, my friends, COD test only require 2 to 3 hours, while the biochemical or biological oxygen demand test requires 5 days. So this is the first one is aluminum flask and the second is heating mantle. So open reflux method, you know, the potassium dichromate is a strong oxidizing agent under acidic condition. Acidity is usually achieved by the additions of sulfuric acid. You also know 0.25 in solution of potassium dichromate is used for COD determination. You know, for all organic matter to be completely oxidized, an excess amount of potassium dichromate or any oxidizing agent must be present. When oxidation is complete, the amount of excess potassium dichromate must be measured to ensure that the amount of chromium 3 plus can be determined with the accuracy. So, to do so, the excess potassium dichromate is titrated with the ferrous ammonium sulfate FAS until all of the excess oxidizing agent has been reduced to chromium 3 plus. Typically, the oxidation reductions indicator ferroin is added during this titration step as well. Once all the excess dichromate has been reduced, the ferroin indicator changes from blue-green to reddish-brown. So, calculations: COD 800 B minus S N divided by sample volumes. You know, B is the volume of FAS used in the blank sample, S is the volume of FAS in the original sample, and N is the normal of FAS. If milliliters are used consistently for the volume measurement, the results of the COD calculation is given in milligram per liter. So, precision and bias. A set of synthetic sample containing potassium hydrogen phthalate and sodium chloride was tested by 74 laboratories at a COD of 200 milligram 0 to in the absence of chloride, and a standard deviation was 30 milligram per liter. Coefficient of variation 6.5%. At COD of 160 milligram O2 per liter and 100 milligrams chlorine per liter, the standard deviation was 40 milligrams per liter. Coefficient of variations 10.8%. So what is the disadvantage? You know, the disadvantage: do not differentiate between the biologically and oxidizable and inert substances. Do not indicate the rate of reactions. So advantage: short time requires for the evaluations. So The objective of this study to combat to reduce the disease burden among human beings and animals. The above topic is taken with the following objective. The collect informations on the collections, treatment, handling, hauling and disposal of medical waste, to determine the level of knowledge and awareness of individual involved in the medical waste in Lucknow hospital, and to determine the physico-chemical properties of hospital waste, water and soil collected nearby the selected hospital, and to examine the water quality of hospital wastewater, to collect the data of the infections and non-infections and recyclable waste in the selected hospital, to access the heavy metals content in water in the study hospital. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.